Hello, I'm Andrew Smith from the Open University, part of the Cisco Cyber Camps team, and today I'm going to demonstrate to you automatic addressing, or I'm going to demonstrate how your smart device, whether it's your phone, or your Alexa, your home automated light bulb, your tablet, your laptop, is automatically given an address as soon as you connect to a network, whether it's again at home or even in a cafe or at school or college or wherever you are. In networking and in cyber, we can give static addresses to devices, fixed permanent addresses. However, with so many devices joining and leaving our networks, it can be a challenge. And also, to get an ordinary home user to add to his or her network an address for each device can be quite challenging as well. So many years ago, they came up with a protocol called the Dynamic Host Configuration Protocol, a very wordy terminology, but it basically means we can give automatic addresses to any device that joins our network. So I'm going to just share my screen now, and you'll be able to see a packet tracer network that I built earlier. As you can see, it's very simple. On the left, we've got a device with a static address. On the right, I've got a server that's going to be giving out automated addresses. And in the middle, I've got a PC that hopefully will get the automatic address, and we will get them to talk to each other. So if we actually just look at the PC here, we can see it's a very simple addressing configuration. And if we actually look at this server and look at its addressing as well, it's very simple. So on one side it's 10.0.0.1, on the other side it's 10.0.0.255 for this server. And I haven't configured it properly yet. And here in the middle, we have actually got a PC that's not set up. But if I actually ask it to get a DHCP address, it's going to come back with an error, and it's going to get an automatically allocated address that won't communicate outside the network. So the PIPA address is a random automatically allocated address until there is a proper DHCP address available. I'm going to put that back to static for now, and then I'm going to go into the server. In the servers on Packet Tracer, there is quite cunningly a DHCP server. We've already got a pool here with a 10.0.0 set up. But what we can do is we can tell it the default gateway, the access address of our server or our exit point on our network. We can tell it where the DNS, the web address lookup, is going to be. So bear with me as I'm just, and then we can say, right, all IP addresses that we're going to allocate will start from 100. And you'll find that sometimes happens on your home wireless network as well. Why? To protect allocated addresses. You can allocate to fixed servers, firewalls, printers, and other devices as well. And we can also say how many people we want to actually run on our network, and that controls the size of the network, the size of the pool, and the amount of congestion or traffic on the network. And also, a lot of home routers cannot handle 512 devices, so we just have to protect that as well. I'm just going to save that so you see it's updated there, and I will turn the service on. Okay, so it's now on and available and listening for DHCP requests. So it's using something called bootp as a protocol to do that. So if I actually go into this device now, go to IP configuration and click on DHCP, whereas before it didn't work and it came up with a default random address. Now it did work, and it gave the first available address. Obviously I started the pool at 100. Here it's giving 100 out, and if to prove the point, I am actually going to add another PC, and by the power of cabling, quickly cable that into the switch, and I'm going to go into that PC, go to the desktop, go to the IP configuration, say DHCP, and as if you guess, it should be now 10.0.0.101. Oh no, it's not found it. Why hasn't it found it? It should have found that then. Ah, yes, because it's not negotiated. See that orange light? It's not connected yet because another protocol called spanning tree is negotiating the connection. I was being impatient, and that's great. That proves the point. So I'm just going to flick it off and flick it on again. And there you go, 101. So even there, I did a little bit of troubleshooting, a little bit of real networking, the cable connection came up, or the wireless connection came up, and it was immediately able to find the address. And it would have automatically tried again, but I just deliberately flicked the service on and off very quickly, which means now that if I go to this PC with this address, so I know it's 10.0.0.100, I can easily send traffic or ping to 10.0.0.1, the static address PC on the left-hand side, or I can ping 10.0.0.255, which is obviously our special server that's sending out our DHCP addresses. But I can also ping our friend 101, the one that's just joined the network as well. They've all got real addresses, and what we can do is say how long the leasing of that address is going to be. So a bit like renting a house or renting a flat, you can rent a DHCP address as well. Sometimes you can set it for a minimum of a few minutes or an hour. Great for cafes like Costa and Starbucks, or for your internet service provider like EE or BT. Sometimes they do it for as long as 168 hours, which is a whole week. And that's because they want your allocation of your device to be static, and they know then what traffic is going to what IP address for cybersecurity reasons, because that way then they don't have to worry about giving an address to you, but they do know who it's going to, and then make it easier to track if there is any cybercrime issues or concerns or technical support requirements as well. So you should find this very useful. Why don't you quickly sort of build up this network, have a go yourself, and explore DHCP and Packet Tracer. I will put a copy of this network up on the CyberCamp site as well, so you too can explore the built network. Thank you very much. This has been a very short session. I am Andrew Smith, and it's been good working with all of you.